In the last video, we took a look at an introduction to Ohm's law here, and we tried to emphasize this form of Ohm's law here, that I is V over R, even though V equals IR is the most common representation of it. We like this side here because it's more sort of a reaction type of thing. We know if we have a voltage and a resistance, it's the ratio of the two that produces the current. This one over here is a bit nebulous in terms of what actually is happening over here, but we like to think of connecting the current pump and some resistance to get the current out, so we use this law. And in that last video, we varied R and saw how R is in the bottom of a fraction, so the larger R you get, the smaller current you get, or the smaller R you have, the larger current you get. In this video, we'll do something a bit more difficult to do. In just two cases, we're going to vary V with the same R and see what happens. So we have the circuit again, the same circuit here, with one resistor in it here. The resistor is the 100 ohm resistor here, so I see a brown, black, brown band on it. And what we can do is, of course, is a bit of a repeat of the last video. We'll go ahead and connect the voltage source to it, remembering that this is a 9-volt battery, so the voltage is 9 volts. So if we sort of sneak in here once again with our meter to make some of these measurements, I think some of them are repeat from last time, but we'll go and do it anyway. We can see here that the voltage across the resistor here is hopefully somewhere, about 8.5 volts. We sort of discussed that the battery is going a bit dead here. We'll use it anyway. So we have about 8.5 volts. And we have this extra wire in the circuit here as we're using as a break-in point so we can make some current measurements. So I'll switch the meter over into the 20 milliamp scale. I'll break my circuit here so I can get into that flow. And I'll connect the green clip lead sort of on the return back to the battery, and the yellow one over here. Looks like I've overflowed the meter. Let me turn to more coarse scale here. And we have that from last time here, that when we're using this 9-volt battery here, we're getting about 87 milliamps. I'm going to sort of write that down right here. So we can have it for later. So 9-volt battery is pushing about 87.3 milliamps through this 100 ohm resistor. So again, what we said we'd like to do now, in the last video we changed R, see if we can change V. So let's just sort of go back and get our heads back wrapped around what this circuit is right here. So here's your basic circuit right here. Move the meter out of the way just for a second here. Now the way we're going to vary V is we're just going to get a different battery. So we're going to pull the 9-volt battery out of the circuit altogether. And we're going to move in just a single solitary C cell. Now these C cells are known to be 1.5 volt batteries. So we're going substantially down from the 9 to 1.5. And we have one of these convenient plastic holders here that looks a lot like the 9-volt battery holder. We snap the battery in and we have access to these nice red and black leads here for insertion into our circuit. So we'll go and do that then. We'll just insert the black lead where the 9-volt battery, the old one, used to be, and the red lead back onto here. And so now we have the circuit built again, but we're running it at 1.5 volts. So see, the current will still come out of the 1.5 volt battery into the 100 ohm resistor, brown, black, brown, out of the resistor and back in around to the battery again. So let's do the same measurements here and see what it looks like. Move the circuit out of the way and get the meter into view there. So the first thing that we'll do is we'll measure the voltage again to see what voltage is going on across the resistor. And I think we know the answer to that. But we'll measure it anyway just for using our meter here. So it looks like, about 1.5 volts. So see, this was 9 before in the last circuit. The V was 9 before up here. Now it's 1.5. So you can probably guess that at the same resistance, the 100 ohms, we'll get a smaller amount of current. So let me just disconnect that now, and I want to go into current mode. So same technique as before. I need to break into the circuit, click this over into the current measurement, the 20 milliamp scale, and I'll capture the current flow that's coming out of the resistor on this lead here as it going back and return on the yellow one there like that. And let's see what we have here. Exact same configuration before, only we're running it with a 1.5 volt battery, and you can see I'm experiencing substantial less current here. In fact, with this 1.5 volt battery, I'm getting about 12 milliamps coming out. So again, it's the same circuit, it's the same resistor, but what I've done now is I've varied V. I went from 9 to 1. I went from 9 to 1.5. And you can see that the current decreased in proportion to the V. So I is proportional to V. The lower the V for the same R, the smaller I that you'll get. Likewise, the larger V for the same R, the larger I you'll get. So we got 87 milliamps for the 9-volt battery, 12 milliamps for the 1.5 volt battery. So Ohm's law holds up in the case where V varies. Now it'd be quite a complicated circuit and or idea to vary both V and R at the same time and see what current you get, but Ohm's law would still hold up. So Ohm's law is always the ratio of the driving voltage to the resistance through a given element.